Greetings, Professor McKee here with another quick Excel tip your finance professor wishes you knew. In this video, we will learn how to use the payment function in Excel to find the payment of an ordinary annuity. In any intro finance class, you will have a unit on annuities, and we professors will always have questions where we give you 4 of the annuity's characteristics and ask you to find the missing 5th one. If you want to ace those questions, this video is for you. So I have prepared here a question asking us to find what the monthly payment of a mortgage will be. Mortgages, like most consumer loans, have constant monthly payments. So mortgages are mathematically the same as an annuity. And if we know everything except the monthly payment of the mortgage, we can solve for that monthly payment. Now, to get started for any annuity question, including this one, it's best to convert this verbal description here into the annuity numbers we need to actually do our calculations, starting with the number of periods. So this is a monthly payment, just like pretty much every mortgage out there, and it's going to be a 15-year loan. So I have 12 payments per year, 15 years, 12 times 15 is 180 payments. My interest rate, I've given the monthly interest rate. It's going to be 0.6%, so 0.006. Do note here, I have monthly payments. I have the monthly interest rate. For any annuity, you need those two to match. Both be monthly, have the same length of time, match the interest rate. Many questions might have you convert the interest rate to get to the right interest rate. I'm keeping it simple and having monthly payments and monthly interest rate be the same. Present value, that is the initial loan amount that I owe after purchasing the house. My loan amount is $250,000, so that's what I put in for present value. Payment, that's what we want to find, so we leave that blank. And then future value. Future value is the amount we owe at the end of the 15-year loan. Well, we've paid off the loan, so it's going to be 0. If it's not 0, we have a problem. So now we have our 4 of the 5. And in many cases, I would need to make an adjustment, changing signs for present value, payment, and future value. These are all cash flows, and Excel functions assume that our cash flows are going in a particular direction. Either cash going out, negative expense, or cash coming in. But here, I don't actually need to worry about that. Future value is 0, so it's cash that's not coming in or out. Payment is what we're trying to find. And then present value is the only cash flow that actually matters. So I could make this negative 250 or positive 250. And it won't affect the outcome because either way, the equation, the function will still work properly. I can't break things by changing signs on present value. So I'll just leave it as 250,000. It's positive 250,000. Think of it as, from my perspective, I've just received 250,000 from the bank, which I immediately then use to pay for my house. And then each payment is then going to be a negative cash flow when I give money back to the bank, as when I'm paying down my debt when I borrowed to buy the house. So in payment, B9, I'm going to type equals PMT and open parentheses. Excel tells me what parameters I need. First up is interest rate. That's the 0.6% per month, so 0.006. I have N per number of periods. That's going to be 180 number of months in my mortgage. Present value, that's the 250,000. And then future value, the brackets mean we have a default value. The default value is 0. Our value is also 0, but just in case we have some weird situation where future value does actually have something, I'm going to put 0 in. And type is for if we don't have an ordinary annuity, the default value would need to be different, but we do have an ordinary annuity. Payments are at the end of each month, so we leave it alone. Close parentheses, hit enter. And I'm going to be paying $2,275 every month as the mortgage payment, paying down interest and principal on that loan. And that is our answer. Now, suppose we wanted to be a little fancier, use better Excel practices. and most importantly, be able to reuse this file for future questions, because there'll probably be additional questions about how to find what the payment is on an annuity. So instead of typing all those parameters directly into this function, we can use cell references, where we write down the values in specific cells and then tell Excel, go to that cell and take that value, instead of typing things in to my formula directly. So rate, we put that in B7. So if I put in B7, B7 is going to then be used, whatever value here is here in B7 will get used in my function. NPER was B6. I can click also, so B6. Present value is B8, and future value B10. And I still get that same $2,275 as my monthly payment. Now, the reason I would do this is, well, a couple of reasons. One is, there's a lot of zeros here in 250,000. It's pretty easy if I'm just entering them into the formula bar to miscount, add an extra zero, not add the right number of zeros. Out here, it's a lot more obvious, because Excel provides these commas and periods as eliminators to know, hey, yeah, I have the right value here. And also, I can change these values here. It's very clear and obvious to me what I'm putting into each of these parameters. And I can say, oh, I have a different loan value, or I have a different interest rate, because I have a different question that I'm trying to solve now. And then I can just immediately have this payment update. So let's demonstrate that. I'm going to change this question. It's no longer a 15-year loan. Now it's a 30-year loan. So I'm going to effectively double my interest payment, or number of payments, on the mortgage. That's going to be 12 times 30, 360 now. And as you can see, my payment updated, my payment was reduced. Now I'm only paying $1,700 every month, but of course I'm paying it for 15 more years. So it kind of evens itself out. And this way, your professor gives you a new question. You can just read the question, make the changes to our parameters down here, and then payment will be automatically updated with the new correct value. So with this single function, you can find the payment of any annuity your professor might throw at you. Do be careful, though, that you're using the right interest rates. I mentioned this earlier in the video. I have monthly payments here. Make sure your interest rates match how frequent payments happen. So monthly payments means we need to have a monthly interest rate. A lot of times we professors will say, give you the annual interest rate or some different interest rate, because we've already taught you how to convert interest rates, and we love building on previous material. So in that case, you would have to convert your interest rate to the right interest rate and then put things in here to solve for your payment. But assuming you've done the interest rate conversion, you will then be able to find any payment for the annuities that your professor throws at you. If you found this video helpful, please comment, like, and/or subscribe so other students can find this too. Happy studying.